Here we have a problem from the AMC 12 math competition in the year 2001. And I just want to say thank you all for watching my videos, even though I haven't been uploading regularly. You guys are the reason that I'm going to start doing that again. So here we're given a polynomial, x cubed plus ax squared plus bx plus c, a third degree polynomial where the roots r1, r2, and r3 follow these rules. So when multiplied together, they equal the sum of all of the coefficients of the polynomial. And when they are multiplied together, they also equal the average of those three roots. And then obviously these two things are equal as well. I just didn't write that one down. And lastly, they give us that the y-intercept of this polynomial is 2, and we're tasked with finding b. So let's jump into the solution. First, what we want to do is note that c is equal to 2, because when x equals 0, the polynomial is as follows: 0 cubed plus a 0 squared plus b times 0 plus c, which is equal to 2. But then all of this stuff here just goes to 0, and that leaves us with c equals 2. So that is our first fact that we're going to be working with. I'm going to just bring this up to the top and erase the rest of this stuff. Okay, so we know that c is equal to 2, but we also have a couple more facts that we can work with. First of all, if we break this polynomial into its roots and write it as follows, we know that r1 times r2 times r3, or I guess I should say negative r1 times negative r2 times negative r3 is equal to c. And that's because those are the only terms with no x's attached. So we can cancel this negative sign and this negative sign because they're multiplied together, and then we'll go ahead and move that one to the other side to say that r1 times r2 times r3 is equal to negative c. But we know that c equals 2, so we also know that r1 times r2 times r3 is equal to negative 2. Next, we know that by this factorization here and by this polynomial construction, that negative r1 minus r2 minus r3 is equal to a. And you might say, how do we know that? Well, to get our x squared term, we want to multiply this x by negative r3. So that'll give us negative r3x squared. And then this x by this x and negative r2. So that'll be minus r2 times x squared. And then r1 by this x, and that gives us minus r1x squared. And these are all of our x squared terms. And so if we factor x squared out of that, we get minus r3 minus r2 minus r1 all times x squared, which means that minus r3 minus r2 minus r1 is equal to a. So let's go ahead and bring that to the top, and then we should be able to finish this problem off. Okay, so I went ahead and rewrote that fact up here at the top, and I just switched the minus signs around. Instead of being minus r1 minus r2 minus r3, I just put the minus on the a side instead. But now we can use this equation here that tells us that minus 2, r1 times r2 times r3, is equal to negative a divided by 3. But now, if we divide negative 1/3 from both sides, we get 6 equals a. And now that we know that 6 equals a and c equals 2, we can use this fact here, which tells us that minus 2 is equal to 1 plus a plus b plus c. And then we can substitute in 2 and 6 for c and a respectively. That gives us negative 2 equals 1 plus 6 plus b plus 2, which gives us minus 2 is equal to 9 plus b, and that means that b is equal to negative 11, which is our final solution. And that's enough for now.